Hello, this is the SizeMove Precursor software walkthrough. So first we'll go to the SizeMove GitHub. We have github.com/SizeMove/Precursor. And we'll go here for the Windows software. For me, that will be Windows. Next, we'll go through the client software. But if you have the slightly newer ones, it'll be SMP1. We'll go to download this over here and download anyway. Open that up and extract it. Once we open that up, we'll hit run anyway. Okay, we have our Precursor client control software here. Assuming your control box is plugged into your computer's USB port, this COM port should be populated correctly. If the incorrect one is selected, you have your drop-down menu here for rectifying that. By default, the baud rate is 250,000, and it's best to leave it as that for now. Our next button here is to connect to the control system. This will engage with the microcontroller inside of the control box and allow the software to send it commands. That button will switch to the disconnect button, which will disconnect the software link there. The next one we have is calibrate distance. When you start this calibration process, it will move to either end of the bed, and that will trigger the limit switches and give us a precise measurement of your total displacement, which allows us to figure out exactly where that bed is on the shake table. It's important to run this at the beginning when you start the software. In fact, it won't let you run some of these unless you switch to an uncalibrated mode, which you should probably avoid doing unless you're very sure of what you're doing, if you're doing a different kind of experiment or some kind of debug operation. For the most part, though, you'll only need to run the calibration the first time you power this on. If you're running a shake experiment with a lot of high velocity motion, then you might need to recalibrate occasionally afterwards. But for the most part, you only need to run it that one time. Next, we have our distance from motor side. This is used for manually picking out an offset. If your experiment has the shake table moving too far of a displacement for its current position, the distance from motor side will allow you to manually put some offset to control where the bed actually is in relation to the motor displacement function. We can type in a desired peak ground velocity and peak ground acceleration and the number of cycles. That will generate a motion plan for the shake table bed. 0.1, let's do some mild values, 0.1 and 3 cycles. We can see here on the plot that the motion displacement will go to 0.2 meters. We have our desired motion velocity peaking out at 0.1, and our ground motion acceleration peaking at 0.1 in either direction. Next, we have option 2. That gives us the function to generate random data, to save that data to a CSV file, or to load CSV ground motion files from actual recordings or from previously made generated data. We hit that generate random data button, we get this pop-up window here, and we can type in the number of seconds we want the random shake experiment to run. I'll type in 10 seconds now, but the maximum is, I believe, 140 seconds. That value should be in the user manual. We can see on the plot here our ground motion acceleration, velocity, and displacement of that random shaking. We can save that to CSV if we want to store those values for later, or we can load the ground motion file to the control box. If we're loading a CSV ground motion file, it'll open up our documents, and we can select the CSV from there and upload it. Last, we have our Send Data to Shake Table button that will bring up a pop-up asking if you want to confirm. If you hit OK, the Shake Table will start moving immediately. So make sure that you're clear of it and that the experiment is ready to be run. There's also a notification down here. Please refer to the performance curves for the maximum acceleration, velocity, and displacement of limits. Excessive values may result in positioning errors. Following intensive ground motion, calibration is recommended to correct positioning errors and ensure operational safety. And finally, we have our Stop Experiment button, which will call up a pop-up and ask if you're sure you want to stop the experiment. You will need to recalibrate after that happens.